and welcome to this What's New in Siemens NX video. In this video, we're going to be taking a look at intelligence-driven design using the all-new Topology optimizer. And to take you through the demo, let's hand over to Paul.
Well, here I am in my NX session. It's a managed session, so I've got access to my Teamcenter database through Active Workspace embedded inside of NX. And I've got some tasks to perform in my inbox. Let's take a look at them. First one here is related to the gearbox bracket that Ben's just mentioned. We delve a little further down, we can find out exactly the details of the task. And it's to use Topology optimization study to look at reducing both the weight and the part count of the existing bracket. Now, not only does it tell me what's required from me, but it also gives me the impacted items. So if we take a look down here, you can see obviously one of the impacted items would be the overall assembly. And we can take a look at this in a bit more detail just by opening this up directly inside of NX. Let's take a look at some of the other impacted items. So again, we just go back into our Active Workspace. If I select it, notice that the corresponding geometry in the NX session is highlighted. So we have this cross-probing, particularly useful to understand the impacted items and where they fit within the assembly. And again, if I want a bit more of a level of detail, we can open this up inside of NX as well. So you can see here the bracket and the gearbox. Again, let's just open up the bracket. Now, as you can see from my assembly navigator, there's 14 components currently, so we're looking to reduce that. And if we take a look at the weight, notice that the current value is just over 4 kilos. Now, I've already got the start part of a Topology optimization study done, so let's just go and find that. Again, if I go back into Active Workspace, I'm going to do a search for it. There it is there. And again, let's just open this up inside of NX. Now, what we'll do here is to go through the process of setting up the Topology optimization. So again, we start the optimization feature, open it up, and we have our own environment. And one of the key things to remember about the optimization itself is that it's now an NX feature, which means that if any of the geometry changes, then your optimization feature will also change to reflect any of those modifications. Now, I'm going to perform a study, so I'm going to edit this study. There's a particular analysis type, the objective, I'm going to look for maximum stiffness. I can modify the resolution of the result. Again, you notice that the optimization navigator updates to reflect that. And I'm just going to hide now the original gearbox housing and shaft and the original fabricated part. But before I do that, the stages that I'm going to go through is I need to define a design space. So this is this area, or this volume, if you like, is going to contain the Topology optimization study. So let's just create the design space. So again, I select the box. Notice that it automatically picks up on the material that's been predefined for that particular box. It's an aluminium. And now that's been added into my optimization navigator. Let's just hide some of these pieces of geometry we don't want to see at the moment. So I'll just hide that. And I now need to look at some construction bodies. And these construction bodies will contain geometry that you want to use as a keep out. It'll also contain geometry such as where the bracket needs to be fixed, both the chassis and also the gearbox itself. So let's take a look at the construction bodies. You can see here. Okay, there's several different construction bodies, and I'll explain exactly what they do as we go through and create them. So first things first, let's create a construction body. I'm going to group these together. So this one is going to be keep outs. Okay, and I'm going to specify these two solid bodies. So what I'm asking for there is I don't want to see any of the optimization study encroach into that particular area. I need that to be kept free of any geometry because that's basically where the gearbox will be sitting. I'll just remove those. And now I'm left with construction bodies that are going to define where the brackets fix both the chassis and also the gearbox. And also we need to create some clearance for the shaft so the gearbox can be dropped in to position. So again, let's create some more construction bodies. So again, we'll have another group. This one is going to be the base mounting holes, and I'm going to select these 4 bodies here to define that, and then we're going to create the fixings for where the bracket is attached to the gearbox itself. So let's again create group for these, and again we'll select these 12 solids here that define where the gearbox mounting holes are going to be. Again, all in while you can see them being added to the navigator. And then the final one is going to be the clearance for the shaft. So again, let's just call this shaft clearance. And it's going to be a keeper. I'm going to give it an offset of 10 millimeters. Again, select the body, you can see the offset's been applied, and those are my construction bodies defined. So the next stage would be to add some optimization constraints. I could add some shape constraints, but in this case I don't need to. So let's add optimization constraint. And apart from obviously reducing the part count, the other part of the study was to reduce the weight. So I'm going to specify that I need this new bracket to be equal to or less than 2.75 kilograms. I need some constraints. So every topology optimization study would require some analysis constraints. And what I'm doing is I'm going to select these 4 faces here to be fixed. Now, there's a set number of load cases that I want to add, and I'm going to specify 4 specific load cases. So again, there's a default one, but I can just add another 3 very easily. And I also want to add that fixed constraint into each of the other subcases. And it's easy to do. I can just literally just drag and drop into the subcase. So the final piece of the puzzle, if you like, is to add some analysis loads. Okay, so I can specify a vector or a component. In this case, I'm going to go for a vector, specify a value, and now I need to attach these loads to areas of the bracket. So these fixing holes, for instance. So again, I just pick on the faces and attach these loads to the one side of the bracket and then the other side of the bracket. And I would do that for each of the subcases. Slightly different loads, slightly different direction, but it would be done for each one of the subcases. And then you utilize all of these subcases during the optimization study. When those were completed, I would then go into the optimizer itself and start the optimization study. Now this took around 5 or 6 minutes to do. I'm not going to do it here in this, live in this particular session, but I do have one that I've already completed, and we can take a look at that. So let's remove the construction bodies. Let's bring back the gearbox housing and the shaft, and bring back the one that I've already completed. And there you can see it. So again, I've got that clearance that I set, so I could bring the gearbox in. I've got that all those key part areas as you noticed again, so there's no geometry inside of here. And I've got the construction bodies that I used for the base mounting holes and the gearbox holes included in there.
Thanks for joining us. In the next video, we're going to be taking a look at integrated design simulation. We hope you enjoyed the video, and we'll see you in the next one.